Next one's a little bit tricky, but let's have a go. So, the instructions are to find values of A and B that make this statement true. So I'm just going to start by looking at what is on the left-hand side. Actually, no, let's look at the right-hand side first. We've got two terms here. One of them is a constant term. It's just a number. And the other one is a term that has a square root in it, so it's the surd term. Okay, now if I just do an example over here, if you've got 1 plus 7 root 3, for example, this is the constant, just a term, a constant term. This is a surd term. There is no way I can put those two together. Okay. All right, so let's look at the left now. I'm going to use FOIL, so I'm going to do, because I've got a multiplication sign and I've got an addition times and a subtraction. So A times 2 is 2A. First outer is minus A root 2. I've just changed the order, but I'm multiplying, so that's okay. Plus root 2 times 2. Again, I'm going to write it as 2 root 2. It's just convention to write it that way. And then minus, because it's a plus times a minus, root 2 times root 2. So that gives me 2a minus a root 2 plus 2 root 2 minus, and this whole thing is 2. What I'm going to do now is actually put all the constant terms together, all the surd terms together. So the constant terms are this one and this one. So I get 2a minus 2, and then minus a root 2 plus 2 root 2. So this bit here is the constant term, and this bit here is the surd term. Now, because there is an equal sign, those two things have to be the same. Just like if you have 3 plus 4x, you can't have 4 plus 3x being equal, okay? Actually, that's a lie. You can, because x is unknown. No, in this case, because root 2 is something definite. So 2a minus a minus 2 has to be equal to the constant term here, which is 4. Gives me 2a equals 6 and a equals 3. And then the surd term on this side is minus a root 2 plus 2 root 2 equals minus b root 2. But a is now 3. So minus 3 root 2 plus 2 root 2 has to equal minus b root 2. And then minus 3 add 2 is minus, I'm just going to put a 1 to make it clear, minus 1 root 2. And that has to equal minus b root 2. So the only possible value that b can have is 1. So b equals 1. Okay, nasty question. I can give you another one of those examples if you need it. On to logs. So our basic log is log base 2 of 8 equals 3, if and only if 2 to the 3 equals 8. They want this in exponent form, so the base is 4, cubed is 64, which is true. And this time they're asking me to evaluate, so some of you like to put an X there, others of you like to put a box, others of you like to just leave it blank. So I'm going to do if and only if, and I'm going to think what goes there, the base. The bit that I don't know is this, I'm going to use the box, equals 27. So I need to raise 3 to the power 3 to get 27. So that's the answer. Log base 3 of 27 equals 3, because 3 to the 3 equals 27. This is the instruction was let's have a quick look what the instruction was. It's to evaluate. So let's look at each one in turn. You can do things with the 3. Some of you would probably want to deal with that. If it's necessary, then we'll do something with the 3. For now, let's have a look at each log individually. So I've got log base a of a squared. I'm going to do my if and only if statement. A to the power of something equals a squared. Now the only thing that will make this statement true is a 2. So this has to be 2. So far I've got 3 times 2 plus, I'm going to do the log over here, log base a of 1 equals something, if and only if a to the something equals 1. And the only statement that will make this true is a 0. A to the 0 equals 1. So this is 0, which gives me 6 plus 0, which is 6. Blank page. Oops. Okay. Now we're asked to use logs to expand this time. So there's a division here, which I can split as a subtraction. So log base b of x minus log base b of x minus 2 squared. I've then got a rule that says that if I've got something here, it can go right at the beginning there. So that gives me log base b of x minus 2 log base b of x minus 2. Let's think about if there's anything else we can do. Can I think of a link between b and x to get from b to x? No, I can't. So that I can't simplify any further. I'm not allowed to split this. There's no rule that helps me with log of x minus y. Oops. There is no such rule. So that is all I can do. All right, next one is solve for x. So remember the trick is to express, these are very deliberately chosen numbers, express both sides as powers of the same base. So both of these are powers of 2. So instead of 16, I'm going to write 2 to the 4. And instead of 1/8, I'm going to write 2 to the, well, I need to flip and I need to turn the 2 into an 8, so I need to cube. So it's going to be to the minus 3. The x minus 1 is still there. Now I can apply the rule of a to the m to the n. So 2 to the minus 3 brackets x minus 1. Lots of you will lose this mark here. I'm just going to do that on the side. Minus 3x minus 1 is minus 3x plus 3. So 2 to the 4 equals 2 to the minus 3x plus 3. And then those two things, because I've got the base of the same, 2 to the something equals 2 to this, they have to equal each other. So 4 equals minus 3x plus 3. I haven't got the space, but you subtract 3 from both sides, gives you minus 1 equals minus 3x. Divide both sides by minus 3, gives you x equals 1/3. I can't think of any simplifying, so let's just do, remember, if nothing else works, if you've tried everything else, do if and only if. X to the 1/4 equals 2. Now think very carefully what a power of a quarter is. A power of a quarter is a 4th root. So I need to start with a number such that when I 4th root it, I get 2. And the number is going to be 16, because the 4th root of 16 will give you 2. Okay? Okay, so here all the bases are the same, but I can't do any simplifying here, no simplifying here, no simplifying here. You can probably guess that we're going to apply the rules. So I'm going to start by just merging these two together. I'm allowed to do that because the bases are the same. So log base a of 15 equals log base a of those two multiplied together. Okay, and then there's the rule that says if log base a of x equals log base a of y, the statement that follows is that x is equal to y. So 15 is equal to 5x, which gives me x equals 3. Similar question again, but this time I'm going to use the power rule, so that one goes up there. So log base 2 of x cubed minus log base 2 of x squared equals 5. I'm now going to merge these two together. Log base 2 of, it's a subtraction, so I'm going to merge it as a division. X cubed over x squared equals 5. That gives me log base 2 of x. Those two cancel out, yeah, equals 5. I'm running out of things to do, so I'm going to do if and only if 2 to the power 5 equals x, and 2 to the power 5 is 32. Another log one. Okay, this is a pretty nasty one, but I think we can handle it. So, always inspect first. Can I figure any of these out? And actually, yes, I can. I can figure this one here. Log base 64 of 8 equals something. Hopefully you realize there's a power connection between those. So 64 to the power something equals 8. Well, if you think about what you need to do to 64 to get 8, you need to square root it, right? And a square root is a power of a half. Okay, convince yourself that that statement's true. Square root of 64 equals 8, which means the number that went here was 1/2. So this whole thing here is 1/2. And I've got log base 4 of 12 minus 12x minus 4 minus 1/2 equals log base 4 of x. Now, you probably want to combine these two together, but they're on different sides. So what I'm going to do is I'm going to put this whole term, I'm going to subtract this whole term from both sides, and I'm going to add the half. So it gives me log base x of 12x minus 4 minus log base 4 of x equals 1/2. Okay, so I've just added a half to both sides and subtracted log 4 of x from both sides. Now I can merge those two together. Log base 4 even, of 12x minus 4 over x, I've merged those as a division, equals 1/2. Okay, I'm running out of things to do, so if and only if 4 to the 1/2 equals 12x minus 4 over x. Now, power of 1/2 is the square root, so 4 to the 1/2 is the square root of 4, which is 2. And I now have a linear equation. Let's multiply both sides by x, gives me 2x equals 12x minus 4. Collect the x terms, I'm going to collect them on the right. 10x equals 4. X equals 10 over 4, which should cancel down to 5 over 2. Lovely. Last question. Right, so this says, what was the initial, this is the formula, first of all. And n is the number of weeks after the farm was established, so after the beginning of the whole process. And p is the population. Right, so the initial population is at the very beginning, so when no weeks have passed, so when n is 0. Gives me p equals 50 times 1.07 to the power 0. The whole of this is 1, so it's 50, which is no coincidence. That number here is always the original amount. After 7 weeks, we've got 50 times 1.07 to the power 7. Okay, so type that into your calculator. I don't have one right here. In the test, it will actually be a non-calculator test, so here we would put some numbers that are user-friendly. But you figure out the answer to that. Okay, and then it says, when will the population reach 500? So when will P be 500? So I substitute that into there, times 1.07 to the power n. So we want to eventually make n the subject. Let's get rid of one layer at a time. Let's get rid of the 50 first. Divide ourselves by 50. Divide by 50 gives us 10 equals 1.07 to the n. and then we apply log base 10 to both sides. So log of 10 equals log of 1.07 to the n. I can apply my power rule that the n goes right at the beginning. Log 10 equals n log 1.07, and then making n the subject, n equals, divide both sides by log 1.07, log of 10 over log of 1.07. Like I said, this is going to be a non-calculated test, so you can leave that as your answer in this case. Don't try and do any cancelling here or anything else. There's no rule to help you with that. And we are done.